Right, so in this video I'm going to have a look at the Leaving Certificate Higher Level Maths Paper 2 for 2019, question 4. So what we've got to do here first is just show that the cos of 2 theta is equal to 1 minus 2 cos 2 theta is equal to 1 minus 2 sine squared theta. So what I'm going to do first is just look at the left hand side, and if you look at your trig identities and look for cos 2 theta, you'll see that that's equal to cos squared theta minus sine squared theta. Now we've got to make this look like the right hand side. So if you look at the right hand side here, you can see you've got a sine squared theta. So we have a sine squared theta here, and we have a cos squared here, so we don't want a cos squared, so let's try and get rid of this. Again, from your tables, your trig identities, you can see that cos squared theta is 1 minus sine squared theta. So cos squared is just 1 minus sine squared, and we have our sine squared here. So we have 1 minus sine squared, so that's going to be 1 minus 2 of these sine squared thetas, and that's equal to the right hand side. So that's it, that's that's done, if you like. So 1 minus 2 sine squared theta, we can see that's what we have here on the right hand side, 1 minus 2 sine squared theta. Okay, so that's part A finished. Let's have a look at part B. So in part B here we have to find the cosine of the acute angle between the two diagonals of the cube. So we have this cube here. So we have the diagonal going from this corner to the opposite corner up here on the opposite face, and the same going down along here. We have another diagonal. So we've got to find the cosine of this angle here between them. So really what I'm going to do here is you've got to take a few steps back here and work on a few different triangles, a couple of different triangles. So you can see this really is made up of a number of right angle triangles here, so I'm going to work on those and see where we end up. Now let's see, I'm going to start down here at the bottom, and I'm going to look at this triangle here. So from here down to here and across here. Now what I'm going to do as well is just call each dimension of the cube x. So the length, the width, and the height of the cube is going to be x. So I'm going to work out this diagonal along here. We'll call that y, let's say. So let's just do that. So if we call this y here, we have a right angle triangle here, so it's really just this kind of thing here. So we have our x, and this is the diagonal along the bottom here, which we'll call y. Well, using Pythagoras' theorem here, we can see that y squared is equal to x squared plus x squared, so y squared is equal to 2x all squared. So that would mean y then is just equal to the square root of 2x squared, so that just means y is equal to the square root of 2 times x. The square root of x squared is just x. Square root of 2 is square root of 2. Okay, so this diagonal along here then is just going to be square root of 2x. So this is the square root, whoops, let me just write that in here, square root 2 times x. That's this distance along here. Okay, so now what I'm going to do is look at another triangle. So I'm going to look at another right angle triangle. So it's going to be this one along here, the one we've just worked out. So it's going to be this one along here, up along here like this, and then along this diagonal here. So it's this triangle here I'm looking at now. This is a right angle triangle here as well. Okay, so we have two of these sides, so I can find the length of this diagonal that's part of our actual question. So let's look at that part. Well, we have, let me just draw it first actually. We have these three sides here, we have a right angle here, and we know that this is the square root of 2x along here. We know that this is x, and I'm going to work out this length here. So let's call that let's call it z, for example. Okay, we've already used y, so let's use another letter z here. Now, using Pythagoras' theorem again, you've got z squared is going to be equal to the square root of 2x all squared plus x squared. So that will give me z squared is equal to, well, we've got to square both of these. So square root of 2 squared is just 2, x squared is x, and then we've got an x squared here. So that will give me z squared is equal to 3, sorry, this should be squared here, that will give me 3x squared here. So that means z then, z here is just going to be the square root of 3 times x. So you square root the 3, square root the x squared. So this distance up along here now is root 3x, root 3x. So let me just write that in. So this distance up along here is root 3x. So that's write it in green actually, since I have that triangle in green. So it's going to be root 3x. That's this distance up along here. Okay, so we're just about there. We're looking at this triangle here now. That we're going to look at this triangle here. So let me just do that. Might do that in a slightly different color. Let's see. We've got here. So I'm going to look at this triangle here, which is the triangle that we're really interested here. Whoops. Let me just do that again. So we're going to look at down here, up along here, and out to here. Not quite right, but you get the idea. We're looking for this the cosine of this angle here marked in black. So let me just draw that. So we have this distance down here, we have another distance up here, and another edge here, and we are interested in this angle here. Let's call it theta. Okay, well, we can see that this distance up along here, is just going to be x. So this distance here is just x. Now let me just write that in here. So we got x along here. What about these two distances? This distance along here, for example. Well, we know from here to here is root 3. So from here, this corner to here is root 3. So halfway along is just going to be root 3 over 2. So this distance here is just going to be root 3 over 2x. This distance down here is going to be the same. That's going to be root 3 over 2x. So this is our triangle. It's not a right angle triangle this time. It's a non-right angle triangle. So we can't use Pythagoras' theorem here, or sine cos tan as such. Not directly anyway. So what I'm going to do here is use the cosine rule. Because remember, the question says, or the question asks us to find the cosine of the acute angle. So there is a cos theta, if you like, in the cosine rule. So that's why I'm looking at the cosine rule in this case. So let's have a look at that. Now, cosine rule is just, generally speaking, it's a squared is equal to b squared plus c squared minus 2bc cos a. Now that's when you have this kind of thing here. So if you have an angle A here and a side A, so this would be B and C here. So we have something similar here. Now let's just apply it to this triangle here. So it's going to be x squared is equal to root 3 over 2x squared plus this one here, root 3 over 2x, again all squared, minus twice these two sides, root 3 over 2x times root 3 over 2x cosine theta. That's applying the cosine rule. So let's work all this out and see where we end up. Okay, so we have x squared on the left hand side. We've got to square this here. Well, if you square root 3 over 2, square root 3 you get 3, square 2 you get 4, square the x you get x squared. Here same thing, square the root 3 you get 3, square the 2 you get 4, square the x you get x squared. Now over here, well, this is all multiplied here. We've got 2, this minus 2 here if you like, multiplied by root 3 over 2x multiplied by root 3 over 2x. So this is 2 over 1. So this 2 here will be divided by one of these 2's. So we just get 1 here, minus 1. So really what we end up with here is root 3x times root 3x. So that will give us 3x squared. That's on the top. And on the bottom we've got 1 times 2. So that's just 2 here on the bottom. And then we have our cos theta as well. Okay. Now let's keep going. So we have x squared here. So we've got to add these two here now. So we have 3/4 plus 3/4. So that's just 3 over 4 plus 3 over 4. So that'll give us 1.5, or just 3 over 2, 1.5, 3 over 2x squared minus 3 over 2x squared cosine theta. So we want to get cosine theta on its own here. Now if you notice here, really you've got 3 terms in this equation. You've got this term here, you have this term here, and you have this big term here as well. Now in each of these you can see you've got an x squared, so we can divide across by x squared. So if you divide this by x squared, you'll get 1. If you divide this by x squared, you'll get 3 over 2. If you divide this by x squared, you'll get 3 over 2 cosine theta. Okay, next line. Now I'm going to bring over the 1.5 here. This is 3 over 2. Bring this over to this side. Subtract 1.5 or 3 over 2 from both sides. So on this side here I'll end up with, well, this is 1, this is 1.5, so I'll end up with minus a half on this side. And I have minus 3 over 2 cosine theta on this side here. Okay, so the last thing we've got to do then is just divide minus a half by minus 3 over 2. So it's a half divided by 3 over 2. So that's just a half multiplied by 2 over 3. So that will give me, this will divide by this here, and we'll just end up with 1/3. So in other words, when I divide minus a half by minus, it'll give me plus. When I divide the half by the 3 over 2, I'll get 1 over 3. So that's cosine theta. And that's it really. That's all we were asked to do, I think, in this question. Find the cosine of the acute angle between the two diagonals of the cube. So that's this black marked angle here. So we found that the cosine of that angle between the two diagonals as being, we call it theta, and we found that the cos of theta is 1/3.